There is a tooth, longer than a human hand, resting in a museum drawer in Lima. A tooth from a beast, capable of crushing a car as if it were made of clay. Some even claim this terrifying predator was responsible for the extinction of the Megalodon. But the most disturbing part is that, according to some researchers, this creature may still be lurking somewhere in the depths of the ocean. You have never seen the ocean it lives in. Almost no one has. This is a world we were never supposed to see. For 20 million years, one rule governed the open ocean. The largest predator wins. Size was the answer to every problem. Size meant longer dives, deeper reserves, harder bites, wider hunting range. Size meant that when a 50-ton shark crossed a whale bay, the water emptied. Nothing negotiated with a mouth 2 meters wide. Otodus Megalodon was the final expression of that rule. It reached lengths exceeding 18 meters. Some estimates push past 20. Its bite force is calculated in ranges that dwarf every living predator on Earth combined, somewhere between 108,000 and 182,000 newtons. Its teeth, serrated like steak knives and thicker than a fist, have been recovered from every continent except Antarctica. It hunted in warm shallows and in cold currents. It ate baleen whales, dolphins, seals, smaller sharks, and, based on the bite marks left in ancient bone, almost anything else that swam. There was no rival. There was no ceiling. Fossil sites tell the same story from opposite ends of the planet. The Pisco Formation in Peru, where you find that Lima tooth, and thousands like it. Sharktooth Hill in California, where amateur collectors still fill jars in a single afternoon. Bone Valley in Florida. The North Sea coast. Every warm shelf on the ancient globe carries the same signature. A top predator that owned every layer of water it touched. And then, roughly 3.5 million years ago, the ceiling arrived. Megalodon fossils thin. Then they stop. The rule of the ocean was about to invert. For a long time, we blamed the sky. One theory pointed to a supernova, a star that detonated somewhere within a few hundred light years of Earth, washing the upper ocean with a bath of cosmic radiation. Traces of iron, 60, an isotope produced almost exclusively in stellar explosions, have been found in deep-sea sediment layers, corresponding roughly to that era. The idea was elegant. A distant star died. Its death propagated outward through the void, and when it reached us, it cooked the surface layers of the sea, and the giant sharks that hunted there had nowhere to hide. But the timing did not fit. When researchers re-examined the Megalodon fossil record more carefully, Robert Bosenecker's team in 2019 was the sharpest revision they found, that the last confirmed teeth predated the supernova signature by roughly 1 million years. The shark was already gone when the sky lit up. Whatever killed it had been working earlier and closer to home. A second theory blamed the whales.
As the Pliocene cooled, some whale species shifted their migration patterns toward polar waters, water too cold for Megalodon's metabolism to handle for long. The food walked away. The predator starved.
This explanation still has defenders. It is probably part of the truth, but it does not explain everything. It does not explain why Megalodon disappeared from tropical and temperate seas too, where warm water prey remained abundant. It does not explain the fossil evidence of overlap and competition. It does not explain the small, sharp, quick shape that appears in the same layers, becoming more common as the giant becomes rarer. Something else was in the water, the cracks. Look closely at the sediment layers from the late Miocene and early Pliocene, and a pattern begins to emerge. Megalodon teeth are still there, still enormous, still terrifying. But next to them, in rising numbers, appear the teeth of another shark. Smaller, sleeker, faster, recognizable. The great white. Not exactly the modern great white, but its direct ancestor. A lineage called Carcharodon histalis, and then Carcharodon carcharias. These sharks reached maybe 4 to 6 meters at maturity, a fraction of Megalodon's mass. On paper, no contest, but paper is misleading, because the great white is not built to fight the Megalodon. It is built to eat before the Megalodon arrives. Studies of dental chemistry, the isotopes locked inside enamel, particularly zinc isotope ratios, recovered from fossil teeth in 2022, have revealed something unsettling. The diets of juvenile megalodons and adult ancestral great whites overlapped almost perfectly. They hunted the same prey. They crossed the same coastal shelves. They chased the same tuna schools, the same young seals, the same slow calves in shallow bays. Megalodon needed approximately 100,000 calories a day to maintain its body. Its young, growing in nursery waters along ancient coastlines, needed enormous amounts of food just to reach the size at which they could hunt whales. And in those nursery waters, crossing through the same shallows, was a smaller shark that could turn in the width of a fin, that could accelerate in a blink, that could take a seal before the young megalodon had even registered its presence. The giant did not lose a war. It lost 1,000 small meals. Every stolen fish was a fraction of a calorie subtracted from a body that could not afford the loss. Every empty nursery was a generation that did not quite reach breeding size. Slowly, across hundreds of thousands of years, the balance closed. And even now, we do not entirely know why the great white succeeded and Megalodon did not. This is where the honest answer begins. What actually killed the king? The best current explanation is not a single assassin. It is a convergence. The seas cooled, prey shifted, coastlines changed as ice locked water at the poles and shallow shelves narrowed into thin strips. The Megalodon's nurseries, warm, shallow bays, where its young could grow with relative safety, shrank. And into those shrinking spaces came a competitor that was faster, more efficient, better tuned to the new geometry of the ocean. The great white did not defeat the Megalodon in combat. There is no fossil that carries the tooth marks of that duel. What the great white did was simpler and more devastating. It outlasted. It outmaneuvered. It took the food that the giant's children needed to become giants. Megalodon was a specialist in a world that was becoming a generalist's ocean. And here is the part that popular retellings get wrong. The great white did not appear as a consequence of Megalodon's fall. The great white was already there, evolving in parallel, sharpening across millions of years of shared water. When conditions changed, one lineage was ready and the other was not. The creature that pushed the king off the throne did not need to be larger. It only needed to be present and patient and precisely the right shape. It is still there. It is still patient. It still has exactly that shape. The modern great white is not a relic. It is the surviving branch of a competition we can barely conceive of, a competition that outlasted the existence of the human species and ended with one predator on the throne and the other reduced to teeth in a drawer. Every modern great white carries that history in its body. The serrated triangular teeth, so similar to megalodons, that early paleontologists assumed they were the same animal. Louis Agassiz himself lumped them together in 1843. The vascular structure that retains heat and allows it to hunt in colder water than most sharks can tolerate, a trait called regional endothermy, shared with tuna and almost nothing else in the shark world. The ambush strategy, the vertical strike from below, the strategy Megalodon itself is thought to have used against whales. The great white did not just replace the Megalodon, it inherited the Megalodon's methods. Watch a modern great white emerge under a seal off the coast of South Africa. The shark rises from deep water, invisible until the final second, and hits its prey with a force that launches a 90-kilogram animal completely clear of the surface. That strike is a memory. That strike is the ghost of a hunting pattern that once brought down whales the size of buses. The scale has changed, the pattern has not, and the pattern keeps evolving. There is a place off the coast of Australia, the Neptune Islands, where researchers have documented great whites cooperating in ways sharks are not supposed to cooperate. Not hunting in packs exactly, but watching each other, learning from each other's kills, sharing information without contact, the way wolves do at a distance. This is new science. The papers are still coming out, but the behavior is old. The behavior has been there the whole time. We just were not looking. The zones we have not mapped. Here is where the story turns strange, because the great white story is not finished. We assume we understand it. Lest we assume that because we have filmed it, tagged it, cage dived with it, sold it as the villain of a horror movie and as a conservation icon. We know what it is. We do not. We do not know where great whites breed. In more than a century of study, no one has ever observed great white mating in the wild. Not once. No researcher, no fisherman, no diver, no submersible. Nobody has recorded the birth of a great white pup outside of dissection evidence. Pregnant females, caught by accident, opened up on the deck of a boat. The nurseries have been localized to only a handful of places, and even those are only partially understood. There is one off Long Island, one off Baja California. Rough coordinates, nothing more. We do not know where great whites go on their deepest dives. Tagged individuals have been recorded descending to depths exceeding 900 meters. One, tracked by Michael Domier's team, hit 1,280 meters into the cold darkness of the mesopelagic zone and hovering there for hours. We do not know what they are doing. We do not know what they are eating. We do not know why an animal built for coastal ambush under sunlight repeatedly abandons the sunlight and disappears into the twilight. We do not know how big they can get. The largest reliably measured great white was just over 6 meters deep blue, filmed off Guadalupe Island. Anecdotal accounts from fishermen and old whalers and occasional scientific expeditions describe animals significantly larger, 7 meters, 8. These reports are not evidence, but they are not nothing. They accumulate at the margins of the record like the fossils that first told us Megalodon existed at all. The ocean is very large, and great whites, unlike Megalodons, are still in it, moving through it, doing things we cannot see. A rhythm older than us continues in the dark water, the depth where everything inverts. Descend past 300 meters, and the world we understand ends. Light thins to a blue so deep it is almost violet, and then to nothing. Pressure begins to crush. Temperature falls toward freezing. The animals that live here look wrong to us because we evolved in the wrong place to judge them. And in this zone, the great white, an animal we categorize as a warm-blooded coastal hunter, appears. Recent tagging studies have documented great whites making repeated, deliberate dives to these depths. Not accidental, not brief. Structured dives with distinct patterns, maintained for extended periods, occurring at specific locations across the world's oceans. There is one region halfway between Baja California and Hawaii. Researchers call it the White Shark Cafe, where dozens of tagged individuals converge every year and spend months making vertical migrations. Up and down, up and down, hundreds of meters at a time, in a zone with no seals, no coasts, no obvious food. We still do not know what they are doing there. The leading hypotheses fall into 3 camps. One says they are feeding on mesopelagic squid and lanternfish, exploiting a food layer no coastal seal population could sustain. One says they are mating, that the cafe is the breeding ground no one has ever seen. One says something stranger, that they are following a magnetic feature, a geological seam in the Pacific floor that channels their navigation. None of these has been confirmed. All of them require the great white to be doing something for months at a time that no shark biology textbook accounts for. Some researchers now suspect the great white is a partial resident of the deep sea, that the version we see at the surface is only the visible fraction of its life, the tip of an animal whose true habitat is darkness. If that is true, everything we thought we knew about the shark is incomplete. It also means the competition that killed Megalodon may not have ended. Because the deep water is where the last Megalodons would have retreated, if any retreat was possible. Cooler, quieter, farther from the great white's coastal domain. And the deep water is now, apparently, where the great white goes when the surface no longer contains it. There is no evidence that Megalodons survive in the abyss. The metabolic demands of a warm-blooded 18-meter predator make it nearly impossible. The prey base does not exist. Oxygen levels will not sustain it. Every serious scientist will tell you the Megalodon is gone. And still, the questions do not close. Where do great whites go? What are they hunting at 900 meters? Why does an animal we thought we understood keep disappearing into a zone we have barely begun to map? We do not know. We still do not know. What the teeth remember. There is a detail in the fossil record that unsettles the scientists who look at it closely. Megalodon teeth are enormous, yes, but some megalodon teeth are enormous and bear marks, bite marks, not from other megalodons, not from anything we have identified. Most of these marks are ambiguous. Post-mortem damage, scavengers on a carcass, the ordinary abrasion of a tooth lost in a fight with prey. But a small number of them are strange. The spacing is wrong. The pattern is wrong. They come from something we have not named. This is not proof of anything. It is a footnote in a discipline that runs on footnotes. Paleontologists have argued over these marks for decades, and the consensus is that they are probably explained by ordinary causes. Probably. The word probably is doing a lot of work in that sentence, because the ocean has not surrendered its census. We discover new shark species almost every year. In 2024 alone, taxonomists formally described more than a dozen. We have mapped less of the deep sea floor than we have mapped of the surface of Mars, roughly a quarter, depending on how you count. The animals we assume we understand keep doing things we cannot explain. The creature that erased the Megalodon was not a monster in the way we picture monsters. It was a smaller shark that was better at being present. It won by attrition, not by combat. It is still winning. It is still down there. The coda. Consider what this means. For 20 million years, the largest predator that ever lived crossed the world's oceans and answered to nothing. It watched species come and go. It watched continents drift. It watched ice ages arrive and retreat. It was the closest thing to a permanent fact the sea has ever had. And it was undone, not by a catastrophe, not by a dying star, not by a single dramatic event, but by a smaller, quicker animal that simply refused to leave. That animal is our contemporary. It is swimming in every ocean on Earth. It is currently making dives to depths we have not explored, in numbers we cannot count, for reasons we cannot explain. Its lineage has already outlasted the largest predator in the planet's history. There is no reason to assume it has stopped evolving. We tell ourselves stories about the Megalodon because it is safely dead. We can put its tooth in a museum and marvel at it because the mouth it belonged to is not going to reappear. That is a comfort. It is the wrong comfort. The lesson of the Megalodon is not that giants are terrifying. The lesson is that giants are fragile. The lesson is that the ocean does not reward the largest. It rewards the one that fits. And something fits, right now, in the water beneath every coastline where a swimmer has ever stood. Something that has been fitting for longer than our species has had a name for it. We do not know where it breeds. We do not know how large it grows. We do not know what it does in the dark. We do not know why it descends there, or how often, or what it finds. We do not know. A rhythm older than us continues in the dark water. And the creature that ended the reign of the largest predator in Earth's history is still moving through it, still hunting, still holding exactly the right shape. The Megalodon is a fossil. The animal that erased it is not. It is still down there, and it has not stopped. It will never stop, because the ocean rewards patience over power, efficiency over size, persistence over strength. And somewhere, at this exact moment, while you read these words, something is gliding through darkness, beyond the reach of our sonar, beyond the reach of our cameras, beyond the reach of our imagination, doing what it has always done, waiting for what it has always waited for, being what it has always been. That tooth in Lima is a warning. We keep telling ourselves stories about the dead giant. The real story was never about the giant. The real story was always about what came next. And what came next is still coming.